So today we're going to be talking about how to use substitution in order to solve quadratic-like equations. So what we want to do is we want to take something that looks like a quadratic equation and rewrite it so that it is. So in this case, we look at our variables. We have x to the sixth power and x to the third power. Well, I can rewrite x to the sixth power as x to the third power squared. So we're going to use substitution. So we're going to let u equal x to the third power, which means that u squared is x to the sixth. So we're going to rewrite our equation. So it's 2u squared minus 7u plus 3 equals 0. Now we're going to go ahead and factor. So first thing I'm going to do is I'm going to factor by grouping. Alright, so I'm going to break that negative 7u up into negative 6u and negative u. So we've got 2u squared minus 6u minus u plus 3 is equal to 0. So we can take each of those groups. So if I look at 2u squared minus 6, I can factor out a 2u and we're left with u minus 3. And then from u plus 3, we can factor out a negative 1. So that's negative 1 times u plus 3. Sorry, u minus 3. Is equal to 0. So then, because I have a common factor u minus 3, we can go ahead and pull that out. So we've got 2u minus 1 times the quantity u minus 3 equals 0. So just like we normally would, we go ahead and set up two equations. 2u minus 1 equals 0, and u minus 3 equals 0. So that means that if I solve for u, I get u is equal to 1/2, and u is equal to 3. But we want to solve for x. So we're going to go ahead and replace u with x to the third. So I'm going to do those over here on the side. So x to the third power is equal to 1/2, or x to the third power is equal to 3. So that means we need to take the cube root of each side. So when I take the cube root of each side, I get x equals the cube root of 1/2, and x is equal to the cube root of 3. So our solution set is x is equal to the set containing the cube root of 1/2 and the cube root of 3. And there's no need for plus or minus because I need them to be positive when I'm taking an odd index for our radical, and we end up having those two solutions.